All right, so we are going to add these two fractions together. And the first thing we do when adding fractions is we factor the denominators completely. In this case, our denominators can't be factored. They're both monomials. There's nothing to factor there. And so what we're going to do now is identify a common denominator. And the way you identify a common denominator is that you look at the two denominators and you say, do they have anything in common? And so when I look at these denominators, I see that they both have an x squared. And so that's part of my common denominator is x squared. That's something that is in both of the denominators right there. Then to that term, I add the things that are in either denominator. So stuff that's in the first denominator that's not in the second, and stuff that's in the second denominator that's not in the first. So in this case, in the first denominator, we have a 3. That's not in the second denominator, but I'm going to put that into my denominator because I have to account for it. So that's from the first denominator. And then in the second denominator, there's a 4. And so that also becomes part of my common denominator, and that's from the second. So what we do is that we take the things they have in common, and then we multiply that by things that are in the first denominator, but not in the second, and things that are in the second denominator, but not in the first. When you do that multiplication, you get 12x squared, and so that's our common denominator. Now, in order to add these two fractions together, I need to make sure that both of the fractions have that common denominator. So when we're looking at the first fraction, it has a denominator of 3x squared. I need to multiply that fraction by 4 over 4 so that I make the 3x squared into a 12x squared. So that's 8 over 3x squared plus. And then the second denominator is 4x squared. I want it to be 12x squared. So I multiply the second fraction by 3 over 3. And when we do that, we get 32 over 12x squared plus 15 over 12x squared. And that is 47 over 12x squared. And at this point, you would make sure that there's nothing you can factor out or cancel out in that fraction. 47 and 12 don't have any common factors, so we're good. The last thing we need to do is we need to identify domain restrictions. So we need to figure out what values of x would make the denominator 0. So in this case, x cannot equal 0. And so we're going to state that here. And that is our answer. All right, so we are going to subtract these two rational expressions. And when we do that, the first thing we want to do is factor the denominators completely. And in this problem, we can actually do that. So the numerators stay the same, but we're going to factor our denominators. So this becomes x plus 2 over 2 times x minus 1. And this denominator, the second denominator, becomes x minus 3 and x minus 1. And factoring the denominators allows us to see what they have in common, and allows us to come up with our least common multiple for these two denominators, so we aren't multiplying by unnecessary things. And so when we look at the common denominator, again, the first thing we're going to do is we're going to write down things that they have in common. Both of these denominators contain an x minus 1. It's in both places. And then I look at the first denominator and say, is there anything else in the first denominator? There is. It's a 2. So that goes into our common denominator. And then we look at the second denominator and we say, is there anything else in the second denominator? And in this case, what's in the second denominator is an x minus 3. And so our common denominator for this problem is 2, x minus 1, x minus 3. And so what we're going to do is we're going to multiply both of those fractions by the pieces of that denominator that they do not contain. So the first fraction does not have the x minus 3 piece, so we're going to multiply by x minus 3. And the second fraction does not have the 2. So we're going to multiply by 2. When we do that, we get x minus 3, x plus 2, over 2, x minus 1, x minus 3, minus negative 2x minus 1, over, oh, I forgot my 2.
Oh, wow.
Right there. Over 2, x minus 1, x minus 3. And now what we can do is we can put the two fractions together over their common denominator. So this is x minus 3, x plus 2, minus 2 times negative 2x minus 1, over 2x minus 1, x minus 3. If you're thinking this is a lot of writing, you are correct. It is a lot of writing.
Wow, that's the answer.
All right, and so we need to simplify the numerator. So the denominator we can leave factored. So we're going to simplify the numerator. And in order to do that, we're going to have to multiply out the x minus 3 and the x plus 2, and we're going to have to distribute that negative 2. And then we'll combine like terms, which is great and oh so much fun. So x minus 3 times x plus 2 is x squared minus x minus 6. And when we distribute that 2 into the parentheses, we get a positive 4x and a positive 2. All of that is over 2 times x minus 1 times x minus 3. Combine like terms, this is x squared plus 3x minus 4 over 2x minus 1, x minus 3. Now, we can identify our domain restrictions here. So we ask ourselves what values of x would make the denominator 0. So the first little binomial there, x cannot equal 1. And the second binomial, x minus 3, x cannot equal 3. And so our domain restrictions are x cannot equal 1 and x cannot equal 3, like that. Now, in 99% of your problems, this is the end, but this is an exciting problem because x squared plus 3x minus 4 can be factored. And so while most of your problems end right here with a binomial or a trinomial on top of your fraction and you just walk away, we can actually factor that trinomial. And when we do, it factors to x plus 4 and x minus 1. Again, super exciting because it didn't just factor, it factored to one of the factors in my denominator, which is super good times. You need to watch for it. And so then our common factors cancel out, and we end up with x plus 4 over 2 times x minus 3, and we still need to state our domain restrictions, so we say x cannot equal 1 and x cannot equal 3. And that's our answer.